Most people still download economic data manually from websites. That approach is slow, error-prone, and completely breaks once you try to scale. If you're doing serious quantitative research, you need a programmatic data pipeline. Welcome back to Code and Capital, where we focus on building institutional-grade quantitative systems, from data infrastructure to portfolio construction, all the way to fully automated research pipelines. In this video, I'll show you how to pull macroeconomic data directly from the Thread API using Python, and more importantly, how to structure it properly for a production quality data pipeline after. Let's jump right into it. Before we jump into the coding part of this video, let's discuss real quick on why our data pipeline is important in the first place. Macroeconomic data is a core input in quantitative finance. It drives regime models, asset allocation, and risk management. Examples include the GDP for the US or other countries, inflation rates, interest rates, labor market data, and more. If your macro data layer is not clean and automated, everything built on top of it becomes unreliable. That's why we use Thread data. As we will see in a couple of seconds, Thread gives you a clean history with all revisions in a time-stamped way, which is very important if you want to run models or if you want to build models and run backtest on that data. Before pinging the Thread API database, let's look at the metadata for our unemployment rate first. Each series comes with an ID, a description, a frequency, and units that you can get directly out of Thread. This is critical because not all series behave the same. For example, some are daily, monthly, or even quarterly. Understanding this upfront avoids downstream issues in your pipeline. To do so, we can just use the function that we just wrote. We use our series ID being unemployment rate, and then we can just set our metadata JSON to thread get. That's the function that we just wrote. We put in the series as our endpoint, and then use our series ID equals unrate as our params here. We can now translate that into a data frame by just saying metadata data frame equals, and then we can pull the series. So if we say metadata df, we can look at it and we can see we get a lot of metadata back. For example, the ID that we put in the first place, the start and end dates, the title for that, and then the actual observation start date. So we see our data, our unemployment rate data point started in 1948. It comes back in a monthly basis. It is a percentage and it gets seasonally adjusted. This is very important for you to understand before you look at the actual time series because you want to know what to expect out of your data. Let's make our first time series call here. The first example we want to look at is the one without revisions, meaning at each point in time, we only pull the latest data point for that time. You don't get the full revision history. So if a data point of 4.5% was reported first and then got overwritten to 4.6, you would only get the 4.6 here. To do so, we can basically do the same steps that we just did. We can pull our observation JSON again, and as you see, it's almost the same call as before. We use our thread get function, and instead of just calling series, we now call series dash observations. Sorry, / observations. We then put in our series ID again, and let's also sort it by saying sort order being descending. That already pulls all our data. Now we create the similar data frame that we had before, where we just say, we look at our observation JSON on observations. And we want to slice it down to just use date and value. All we now have to do is clean up that data a little bit. I'm gonna just copy that in here. We make date and actual date time, we make the value numeric, we sort our values, and we drop all none values. We can now look at our data and see that we got a clean data frame back that goes all the way from 1948, which we expected because we looked at the metadata, all the way to 2026 February. We can plot that data in a nice way and can basically visualize our unemployment rate over time. We can see a couple of spikes over time. Most significantly, the 14.8% during the COVID pandemic. Now let's look at the overwrite case. Macroeconomic data gets revised over time. For example, GDP or inflation numbers are often updated after the initial release. In that case, we want to overwrite the data in our database. This ensures that our database reflects the latest official values. To do so, we're gonna use the same thread get function that we used before, and we start off at the same series observation and series ID call. All we now have to add is an observation start, and we set that to 2025 January, and that's basically just saying when do we want to start pulling the data. More importantly, we want a real-time start. Real-time start is the data published dates. So observation start date is the date the data is for. So for example, I want the January release number, even though it got maybe only reported in February. And real-time start is the date when the data got actually published onto the thread website. We now also need to add a real-time end date, and we want to set that to 9/9/12/31. Running that gives us our same JSON as before, and we already know all of the data frame. So I can just do our data cleaning and conversion into data frames directly here. We can now look at one example. Let's look at this. This one is a good example here. Let's look at the July of 2025. You can see that initially on 2025 8/01, we got a reported value of 4.2%. Then that value got revised in 2026 January 9th to 4.3%. If you would not pull the revised data series, you would never know about this 4.2. You would only get the 4.3 case. That's why it is important to get the actual revisions in. It is also important that you don't use this date in your backtest. You always want to start, or you always want to use your real-time start and real-time end dates, because that is the dates, or those are the dates when the data was actually available to the public on thread. You don't want to start any look-ahead biases here by using the 07/01 date. As a little bonus at the end of this video, let's scale this up. Instead of just pulling one series at a time, let's pull 3 at once. We're gonna pull the unemployment rate, the Fed funds, and the year-over-year inflation here. Year-over-year inflation being in percentage units. All we have to do is we loop over those 3 observation series data points and store them into one data frame. Now we have a consistent macro dataset ready for our analysis, which we could, for example, use in regime models, in factor research, or for our portfolio construction. We can look at those data points in a plot form here as well. We can see that our latest unemployment rate comes in at 4.4%. Our Fed funds comes in at 3.6%, and our year-over-year inflation comes in at roughly 2.5% right now. To summarize our findings, manual data workflows do not scale. The Thread API allows you to build a clean, automated macro data pipeline. You don't want to go to websites and manually download Excel files of macroeconomic data. The Thread API already handles all revisions for you, which is very critical downstream. You just need to structure the data properly, and that enables you to do some quant analysis on top of it. Most people underestimate how important the data layer is. It is foundational if you want to build institutional grade systems. If you found this video useful, subscribe for more content on quant infrastructure, backtesting, and portfolio construction. Next, we will take this macroeconomic data and take it a step further and integrate that macro data into a full regime modeling framework. This was Code and Capital. Rigorous research, practical implementation, and institutional quality thinking. We'll see you in the next one.